Hello everyone, today we'll be teaching you implicit differentiation. Now, let's start with what it is. It is a procedure of differentiating an implicit equation with respect to a desired variables as unspecified functions of x, y. Now, how to do implicit differentiation. First, you differentiate with respect to the x. Next, collect all of the dy over dx on one side. Then, you solve for dy over dx. For example, xy equals 1 can be solved for y equals 1 over x and can be differentiated directly to yield dy over dx equals negative 1 over x to the power of 2.
Before we get into our first example, I have a joke. Why didn't the derivative of secant go to the beach? Because secant tan. Wait. I have another one. Did you see the movie about the x squared's journey to become 2x? It was really derivative. Okay. Anyways, for our first example, we have x squared plus y squared equals 100. So for the first step to find the implicit derivative of the equation, we must derive it. This gives us 2x plus 2y dy over dx equals 0. We then must isolate dy over dx. This prompts us to subtract 2x from both sides and then also divide both sides by 2y. This leaves us with dy over dx equals negative 2x over 2y, which simplifies to negative x over y. This leaves us with the final answer, dy over dx equals negative x over y.
For our second example, the equation that we have is x to the third plus 4xy plus y squared equals 13. So the first thing that you're going to want to do is use the product rule to get the derivative of the equation. So that's going to give you 3x squared plus 4y plus 4x dy over dx plus 2y dy over dx equals 0. From here, you're going to subtract 3x squared and subtract 4y from both sides. And that is going to leave you with 4x dy over dx plus 2y dy over dx equals negative 3x squared minus 4y. And then you want to bring dy over dx to one side, so dy over dx times 4x plus 2y equals negative 3x squared minus 4y. And then you're going to divide both sides by 4x plus 2y. And you're left with your final answer of negative 3x squared minus 4y divided by 4x plus 2y.
And now for our last example, we'll be working with a harder equation of 5 cosine y squared is equals to 3x plus 2y. I'm going to leave 5 as a constant on the outside, and now we'll be using the chain rule with cosine y squared. We'll do the derivative of cosine, which is negative sign, leaving the y squared, and then the derivative of y squared, which is 2y dy over dx, and now we'll do the right hand side, which is the derivative of 3x, which is just 3, plus the derivative of 2y, which is just 2, dy over dx, because we're still deriving y. And now I'm going to combine my negative sign y squared and my 2y dy dx, so I'm going to leave 5 on the outside, and now I have negative 2y sine y squared dy over dx, leaving my right hand side as 3 plus 2 dy over dx. And now I'm going to distribute the 5 into my negative 2y sine y squared dy dx, and I get negative 10y sine y squared dy over dx is equal to 3 plus 2 dy over dx. And now, because at the moment my dy dx's are of different signs, with the plus 2 and the negative 10y sine y squared, I'm going to add the negative 10 to the other side to make it both positive. And at the same time, I'm going to subtract the negative 3 to get dy dx on one side and now have it equal to 0. So now my new equation will be negative 3 is equal to parentheses 10y sine y squared plus 2. And we can factor out that dy dx because both 2 and 10y sine y squared have the dy dx in common. And now we can find dy dx much easier by dividing both sides by 2 plus 10y sine y squared, which will now give us dy over dx to equal negative 3 as our numerator, all over 2 plus 10y sine y squared. And that is how we implicitly differentiate the original equation of 5 cosine y squared is equal to 3x plus 2y.